Okay, I've got a three-phase motor here configured for 230 volts, three-phase line to line. This is a single-phase input inverter that puts out three-phase. I'm running this only on 110 volts here, 120 volts, AC 60 hertz. This inverter from Westinghouse L510, you can get a model, one of the versions here that I've got here is you can put in 120 volts single phase and you get three phase out at 230 volts. So I'm just going to quickly show something I've got here. This motor here is a Baldor motor. I'll zoom in real quick and show the motor. It's an IDM M3534. It's a 56C frame. That means it's got a face here that you can mount on. And it's 3rd horsepower. It's 1725 RPM at 60 hertz. And if there was no friction, it'd be 1800. And this specific one here, you can use it up to 6000 RPM. And that's one of the reasons I bought this. It's got a big 6205 bearing in the front here. So it's got a 25 millimeter shaft here. And then it necks down to 5/8, so it's got a big, huge bearing in the front, and then it's got a regular, I think, 6203 in the back. But I'll zoom back here and show the unit here. When I first got this inverter here and plugged it in today, the knob didn't work. You got to go in and program it, so you either use this, which is the front setting to change the frequency, or you can use the knob. There's a whole bunch of different things. The manual has got just tons of different stuff that you can program in there. So this one I've got is 115 volt input, and this particular one is rated for up to, I think, either 3/4 or 1 horsepower. Now the motor here, what I've got it hooked up is you can either have it for the low set of windings or high. And that's over here on the motor face. And long story short, when it's in low mode, you basically have two stars that are in parallel. And so in high mode, it's all connected up, so you've got a longer bridges on the star. And so this winding configuration here is how you wind it up. And so in the low voltage mode, you have 3 connected to 9, 1 connected to 7, 2 connected to 8. And here's the color codes that are on here. They're all on this Baldor motor. They all have nice lines and stuff. So I just twisted them together and got them here in the input 1, 2, and 3. And then this input here for the 110 is just neutral, and there's a 120 volts there, single phase. In a three-phase motor, there's an extra terminal here that's used. So let me go ahead and just turn this on. And by default, it comes up at 5 hertz. So I did a little preliminary video, and you could actually see the display here. Now it wasn't jumping around. So if I want to change this, what you do is you hold this button down, and then I want to go through and click on the 5 digit. So I'm going to go ahead and just change this to, let's say, 9 hertz. And you hold this button down, and it speeds up. So I could go through here and say I want to change it to 19 hertz. It's going a little bit faster there. And if I go over here and just change this to, see, I went above 60. Now, when you first get the unit, it's only going to go to 60 hertz, because they normally in the inverter, they don't know what type of motor you're hooking this up to. So you can see I got some noise back here. And I took the end bell off here, the plastic cover. I don't know, this is a surplus motor, if it's got a bad bearing or it's just got to be run in, but that's just the nature, kind of what it sounds like. It sounds like it's coming right in the back here. Anyways, when you first get the unit, you can't program this above 60, and you go in to a mode here, which is like on this, and you can set the program to 12 here. It's 12. Hold that down, and I've changed this to be the max frequency to be 90 hertz. That's in the book here, 012 frequency upper limit. So when you first get the unit, you can't go above 60. So I went and changed this to 90, and let's just get back out of here. So you can go through and let me just change this to 690. There's 70 hertz. And you hold the button down. So I'm now using this keypad to change the speed. When I go up to 80 hertz, I can hold this down, move this over, so I'm going to move this digit. Let's go to 90 hertz. And I'm not really having any load on this on here, so I'm not burning this up. This has got actually a heat sink. You can mount, when you mount this on, you want to sink it to something. And then I'll go show you on here. If you want to use this knob, it's not going to work until you tell it that you want to use that knob. So let me go through and turn this off. And go in the manual here and look at, let's look at the parameter 015, is main frequency source selection. And 0 is the keypad, so here's default here, is 0. And I'm going to change it to the potentiometer on the keypad, which is 1. So hold the mode down, and I want to go to group 0005. So I'm going to go down here, 05, and I hold this button down. And it's in 0, which is keypad. I'm going to change this to 1. Then I'm going to hold this down again. It'll say end, then it's taken it. Now just to double check, there it is in 1. So this has been set to potentiometer and keypad. So you can have external analog signals to this. You can use all sorts of stuff. Communication set frequency, so you can get through this bus on here. You can go through and change all sorts of parameters, what you want to have, if you want to not just use this keypad on there. So they use these things a lot of times on production control. So I'll turn this on. Let's just see what happens here. Now the knob is changing the frequency. I'm going to zoom in here, see if we can get some more. The max this knob went to is the 90, which I programmed in there for the max speed. So if I want to go down here to 60, let's see how easy it is to set to 60. Fairly easy. Now let's just go through and look at some voltages across the windings here for kicks. So I'm going to go down here and use the 8060A here, true RMS meter. And just to protect the meter, I've got this set to the 750 volt AC. This is on AC volts. And this is a true RS meter from the 80s. It was actually a very classical meter. So I'm going to go in here like this and look at, let's go look at 60 hertz and just see what voltage we have across the 3 winding. Let's go look at the line just to kick here. There's the input, 122 volts. Let's go look at the frequency. There's 60 hertz, that's the line voltage in. Now let's go look from L2, T1 to L2, or T1 to T2. There's 269 volts. 260, kind of down in there, 268. 269 volts. And it may not read the frequency because it's got the carrier on top of it. Yeah, 4.6 kilohertz. It's reading that instead of the main. So let's go up to 90 volts and just see 90 hertz, which is 1.5 times the base speed. We'll go look at the voltage across the windings. 267, 267, 267. For kicks, let's go down to about 5 hertz. You can also set the minimum speed on here. There's 5 hertz. I think it was 90 volts. Here, 95. I think it was 90 volts when I measured it using setting the speed just with without the pot. It's 90 volts. There it is, 95. 5.4. 10.6 hertz. 124 volts. It's close to 15. We got 43. 20 hertz is 163. It's close to 25, 181. Almost up to 200 volts. There's 40 hertz. 45. 51. So it looks like they limit the voltage so you don't have too much saturation going on there. I'm not sure what the saturation characteristics are on this motor because it's rated up to 6,000, but normally if you want to run a this is actually an inverter motor, so it's probably got laminations that are finer to let it to go up to that. It's a vector duty motor. So I'm going to be doing some tests later on with this on some machinery, and so that's why I got this inverter duty motor. If you use a regular 3-phase motor that doesn't have, it's not rated for inverter duty, you could go, you have to be careful you don't burn it up because you'll reach saturation a lot of times. So when you first get this, all it's going to do is go about the 5 hertz. I think that's the base mode when you first get the unit. Plug it in, it's kind of spinning around like that. You try to grab the shaft over here. Got a lot of torque. Another thing on a motor like this, if you're going to have to try to get power at a low speed, how is this motor cooled? If you try to get a lot of torque out at a low speed, you're limited by the current on this, and you can also go through to where you have cooling issues. This is a self-contained motor. There's no fan inside here. But just be aware, you can't just get infinite torque out at a low speed to get the same horsepower. So you're limited by the amperage of this control. And I got a 1 horsepower, little bit better brand inverter. There are some other ones out there, and the ones on eBay that say they're 3-phase off 120 volts, they say 120 volts 3-phase. They don't say it's 230, so I don't know if that's a typo. The ones that are not as well documented, a little bit cheaper. This one was actually a real good deal. I got this from Marshall Wolf Animation in Illinois, and I think it was only about 130, 140 bucks. And I wanted to get one that had good documentation versus one that's a mystery brand from China. I mean, this may be made in China, but at least I've got something that's a little bit more easy to understand. I may end up getting a cheaper one anyways, but here's the different models on here. This is 115 volt input. That means 1 phase. There's a 230 volt, 1 phase, 3 phase, and a 460 3-phase. So this one here is 115 volt, single phase in, and then I've got up to 1 horsepower output. Over here it says you should go through and have a contactor in the middle and a reactor in case you probably get some hash through there. You can go through and have hook up a switch here to go ahead and have your remote stop and start. Here's the analog for the if you want to hook a pot up, is 0 to 10 volts, and so you have a pot that's on there, to potentiometer to do it. And then there's an RJ45. It looks like there's a communication port you could hook up somehow. I'm not sure here. And on this particular motor, there's also a motor on here. There's a set of connectors here that's for a thermostat over here, and that's just so if it gets too hot, you can rig this thing up to turn something off. And so deep down inside there's a preventative deal that it's a thermostat that'll turn off, and that's the 2 J connectors on here. Thermostat leads is the 2 J connectors. And that's about it. When I first got this, I didn't, let's see if we can go ahead and change this real quick when it's running. Change this to not use the pot. So we want to go back to the keypad. So you hook onto here, and I want to change that to 0. Which is the keypad. Hold this to hold it down. Oop. Let's try it again. I wonder if it'll let me do it when it's running. Hold it down. 0. No. Let's try it when it's off. Now let's try it. Yep. There it's end. End means it's taken the program. So some of the parameters you probably have to stop the unit. Now once you've done that, you hit this button here, you'll see it kind of scrolls down. And I believe you can set the ramp where you want to, how fast you want it to slew back and forth. So just for sanity, I'll show you here across 60 hertz what you got. 269 volts. 269, 269. All over this manual and a bunch of other brands, they all tell you don't hook, you know, the motor up to the line or line up to this. So that must be a big failure mode where people hook up the line to the outputs. This is a doofus factory. They also do have a quick start here out of the box review. This helped a lot. It didn't really go through and kind of point out. First I got this, I was like, why doesn't this knob work? And then I kind of like figured it had to be programmed, and that's where I kind of stumbled on over here. How to change this over. And on this group parameters here, this mode, it's got just, you can go crazy at different types of things. Motor parameters, it's got the conversion volts to frequency you can set here. Volts per hertz patterns. External digital input and output parameters. External analog input parameters. Multi-speed function group. Start and stop parameters. Again, you're supposed to have this unit vertical. Right now, from all I'm doing, this is cool as a cucumber. There's a model number there, L510-101-H1-U. 1 phase in, 3 phase out. And this is cool as a cucumber right now. In fact, the motor's really fairly cool. I mean, I could say this is probably just a couple degrees above ambient. And the real question over here, do I have might have a bad bearing on there. Or, usually inverters kind of make motors sound kind of goofy.